Hey guys, today we're going to be solving LeetCode 994 rotting oranges. I'm going to be solving this problem in Python today, but my code will be applicable to any programming language. Okay, let's start off by reading the problem. So you were given an n by n grid where each cell can have one of three values. 0 represents an empty cell, 1 representing a fresh orange, or 2 representing a rotten orange. Every minute, any orange that is 4 directionally adjacent to a rotten orange becomes rotten. Return the minimum number of minutes that must elapse until no cell has a fresh orange. If this is impossible, return -1. So let's kind of look at our image over here, and we'll look at our first test example, and we'll kind of break down this problem. So as we can see, at minute 0, we only have one rotten orange. So what do we want to do? This is really important what it says right here. Any fresh orange that is 4 directionally adjacent to a rotten orange becomes rotten. So that means that two things, right? So I'm going to make some notes over here to kind of go over essentially what we should be looking for. I'm trying to remember what it is in Python for notes. So the first thing that we have to do is 1, check all 4 directions if rotten. But 2, that kind of goes on this, and I'm going to put this inside of it almost, is kind of show that even though we're checking the 4 directions, we have to make sure that 1, it's in bounds, right? So as you can see right here on this first orange, if we were to go above or we would go to the left, this would be out of bounds. So we can't check that. So the one thing we have to do is we have to check in bounds. So let's kind of get back to this again. So we're at the 0th index, right? 0th row, 0 column. And we want to check all 4 directions because it's a rotten orange. So what's the first thing that comes to mind on an approach to this kind of problem is I think of like a breadth first search. When I think of breadth first search, I kind of just think of it as like we're going to path out in all directions possible. And in this case, we're going to path out in 4 directions, right? Above, below, to the left, and to the right, while in bounds. So we're going to path out and try to hit everything that we can, right? And so we can see that we do end up hitting 2 things, right? We hit to the right and we hit below. This would be minus like +1 row, -1 column. This would be we stay at the same row and shift over 0 and then +1, right? That'll make more sense in a second when I write out like the directions and stuff. But so we can see at the first minute we've hit 2. Now we have 2 rotten oranges. Now this one that's right here that we had at the 0th index, we don't need to check this one again, right? Because we already know that everything that when we're at this isn't there. So when we kind of think of a breadth first search approach, we do everything that's we can possibly do, and then we just get rid of it, right? So in this case, and we can like you think of it as in a sense of like popping it. We pop it off of the queue or something, right? So we're gonna hit 2 things. We're gonna hit 2 oranges that are 1s. We're gonna want to check 1 if we're in bounds, and if 1, right? Because if let's say at the 0, 1 index, which would be the 0th row, the first column, is a 0, we wouldn't have anything to hit, right? So we wouldn't do that. So when we hit a 1, what do, right? So coming back to the 0th minute, we hit this one, and we're going to push this onto the queue in kind of like our breadth first search. We're going to hit something that's in bounds in one of the 4 directions, and if it's a 1, and we're going to push this on the queue, and then we're going to do everything from that. So we see that, we had it at the 0, 1 index and the 1 index. And then we also, at minute 2, after we hit these, we're going to hit everything that's connected to in a 4 directional, right? And so why it's really important to come back to that thing I was saying earlier, we need to pop those things off the queue, is because if you can see at minute 1, if we were to check all 4 directions, what would end up happening is we would hit this 0th index when we check to the left, and when we are at 1, 1, we would also hit the 0th index when we go above. So that's why it's really important to pop that off the queue after we check it, because we don't want to be rechecking, right? So we hit this at minute 2. We're going to hit these 2 at the 0, 2 index and the 1, 1 index. And then we hit everything that's connected. We hit everything that's connected here. We see at minute 3, we hit this one orange, and then we hit the last one. And then we can do two things, right? After we check everything that's run, after checking all rotten oranges, we need to, if there are, if any fresh remaining, then we return -1. And let me kind of explain why. So let's say that we had an example where we have just, let's say, an orange at the 0th index, and it's a fresh orange, and we have one orange right here at the 2 index, right, at the complete inverse, so the complete opposite side. If we had a rotten orange there and we try to check everything, we only just had 2 oranges here, right? This would not be able to reach this, right? So we know that no matter how much time expires, we would not be able to convert that fresh orange to a rotten orange, which in that case would mean we return -1. So the way that we can do that is that we would do the breadth first search. We would check all 4 directions and we'd push those onto the queue. We'd pop off the current index. And then what we would do is check, hey, is there anything left in the queue? If the queue is empty and there's still a fresh orange, then we know there's nothing else to check. Hence, we can just return -1. So we can kind of see this in this next example here. And to kind of make it a little bit easier, what I'm going to actually end up doing is kind of formatting it in a way that allows us to see it like we would in like an actual matrix, see like how they formatted it. So this is going to be a little bit easier to understand. So let's say we come here, right? We see that we have this rotten orange here, the 0th index. We're going to check all 4 directions, given that they're in bounds. We're going to check above, out of bounds, left, out of bounds, below is a 0. And then we see to our right is a 1. So we're going to push the 0. This is what's going to be in our current queue, is going to be 0, 1, the 0th row and the first column. And then we're going to do BFS on this one. This is going to be the BFS first iteration. And then we're going to do BFS on the second iteration. Now, when is this going to hit? Now, we check above. It's going to be out of bounds. We check to its left. That is going to be not available because you've already, that's already been pushed into the queue. And then we're going to check to its right and below. So now the queue is going to look like, I should say, BFS on queue. And I'll kind of, explain this as I write the code. So now our queue is going to look like this. We're going to have the 0, 2 index, and we're going to have the 1, 1 index. Oops. This is what it's going to look like, our queue. And this is going to be in like actual double brackets, but this is what our queue is going to look like. And then we're going to do everything that is connected to these. That's already been on there. So we're only going to end up hitting what's to the right and below this. And then, so I'll kind of I'll do another just example of this on queue. So now we're going to hit the 1, 2 index. And then again, we're going to have it on, now we're going to have it on the 2, 2. And then after we do this, the queue is going to be equal to empty or null, right? The queue dot length is going to be equal to 0. But we can still see that we have 1 fresh orange, right? So we know that no matter how much more time expires, in this case, we could think of this as that, this is at the 0, right? This is at 0 minutes. This is at 1 minute. This is going to be at 2 minutes. This is going to be at 3 minutes. And then when we get to the end of 3 minutes, we still have there, but we have nothing else in the queue. So we're going to have to return -1. And we can see that that's exactly how we get it here. Right. And the last one, we can just see this is a pretty simple one, right? There's going to be no fresh oranges, which means we're just going to return 0. Everything in here, there will be no more fresh oranges to hit. So that's kind of an important one, but that's a pretty simple test case. Let's kind of go through exactly how we want to approach this problem, right? So the first thing that comes to mind is that we need to be able to, we need to push all the fresh, let's say rotten oranges on a queue. Now a queue data structure follows the FIFO property, which is the first in, first out, which essentially means the first thing that gets pushed in is going to be the first person to come out. You can think of it in a line, right? if you have a line to get coffee and the first person that walks in the store to buy coffee is going to be the first person that's like able to buy coffee, right? It's the opposite of a stack where you have the LeetCode property, which is last and first out. So we're going to have the FIFO, and we're going to push all the round ones into the queue, and we can do the same thing for fresh oranges, where we have a queue and we see all the indices in which there are, you know, a fresh orange, and we have to see if we hit those, or we can just count how many fresh oranges. And I'll explain this why, because we just need to, we don't need to do BFS on the fresh oranges. We just need to, if we find a 1 from a rotten orange, reduce the count by 1, right? Reduce the count of fresh oranges. And we'll do this by iterating over the matrix one time and storing all of the rotten oranges and all of the fresh oranges in one iteration. And then we will come back and we will iterate and do BFS on all of those rotten oranges and see if we can hit all of the 1s. And every time we do, we'll just return, we will just decrease fresh oranges by 1. And so the way that we can do that is that if we hit the same orange that's a 1 from multiple positions, you know, take for example this orange right here, at the 1, 2 index, or sorry, the 1, 1 index, the first row, first column if we're doing 0th based. When we hit this, this will be hit, and I say hit, this will be touched by a rotten orange from the 0, 1 index and the 1, 0 index, right? So it'll be hit twice. We'll just say every time it hits it, we'll just decrease it by 1, right? So that way we don't have to worry about this whole thing of every time an orange touches it, we have to worry about how we touched it before, these kinds of things. This will save us a lot of time. And it'll make our code look a lot cleaner. I'll explain it as I do it, but with that being said, I think it's really good to start kind of building this out. So we want to push all of the rotten oranges on the queue, count all of the fresh oranges, and then what we want to do is just have our directions. And then we want to, while, like, I don't want to like do too much LeetCode, but it's kind of like a, while there's still things on the queue, items on queue, and still fresh oranges. Fresh oranges to traverse. Look in 4 directions in bounds and push 1s on. It's gonna do that, sorry. 1s on queue. Right. So what I'm saying is that we're going to check in all 4 directions of the rotten oranges. And while there's still items in the queue and there's still things to traverse, right, we're going to look in all the 4 directions in the bounds and push the ones in the queue. And then we're going to want to pop from the queue. And what else is there that we need to do? And then if it's a 1, right, we need to push down the queue, and then we increase the time. Time at end. Okay, so let's start writing some actual code now. The first thing that we want to do is have a queue, and we're just going to use a DQ because it's just essentially the same thing. A DQ is a double-ended queue, and in Python, it's just going to allow us to have still the same O1 time complexity when it comes to pushing and removing things from the front and the back of the queue. And we can also move things from the front of the queue, and I'll show you how to do that in a second. So initially, we're going to have our fresh oranges set to 0. I'm going to start our variables right here. And we're also going to have time is going to be equal to 0, right? So the elapsed time is going to be 0 at the start. Now let's start writing some code. So we have rows, calls, and we're going to set this equal to the length of grid. So the rate, the amount of rows are going to be equal to the number of rows, right? So it's going to be the first indice. So length grid and length grid at the 0th index, because we know that all of the column lengths are going to be the same. And that's going to be grid at the 0th index. Okay. So now we're going to try to go through all of the indices in the matrices. So the way we can do that is just by having a double for loop. So we're just going to say for our in range rows for column and range calls, we're going to have if grid at row call is equal to 2, right? So what's going to happen here is if it's a 2, we're going to store this inside of our DQ. We're going to store the indices of this. We're just going to say q dot append. Append is what allows us to push things onto the queue. Right? And then if the grid at row column is equal to 1, we're just going to increase the amount of fresh oranges, right? Plus equals 1. Now what we're going to do is we're going to come back here. We're going to have our directions. So this is the next step, right? We're going to have directions. And we'll just make a list of these directions. So we're going to have 0, -1. This is going to be going down a column. Or sorry, back a column to the left. This is going to be, the next one is going to be going to the right. And this is going to be 1. The next one is just going to be 1, 0. This is going to be going up a row. And our last one is just going to be going down a row. Okay, so this is going to be going down. So our first one here is just going to be going to our right, to our left, above, below. Okay, I'm going to put directions just because it's a little bit better wording. And then next step is we want to iterate over current queue. Now this is really important because coming back to this, when we're building this queue and we're pushing things onto it, we want to think of it as every given minute, right? Now, we would only have 1 minute if we just took the queue as it's growing, right? Because the queue, if we look at our first example, is going to be consistently getting bigger in size. So if we didn't take it over the current length, right, current range length, then this thing would go on forever. So we just need to have our check here though really quick. While the length of queue is greater than 0, greater than 0, and fresh oranges is greater than 0. And then this is what we're going to be doing inside of the while loop, right? So while these conditions are true, while the length of the queue is greater than 0, right, there's still things that are rotten. There's still rotten oranges. And while there's still fresh oranges, right, we want to iterate all over the current queue. So we're going to do that through this loop. And sorry for doing the extra brackets sometimes. I'm so used to writing in C. So for current, this is our current position in range length queue, right? So this is going to be our current length of the queue. So if we look at it in our first test example, the current range, the current size of the queue at the initial time we hit this flow is just going to be 1, right? And then as we see at minute 1, we have 2 oranges. So then now the queue will be 2, but we only want to do over the current size. So that's why we have this. While that, and for all the items in there, we're going to have our row column, and it's going to be equal to q dot pop left. Let me kind of explain what this does. So if you do pop in DQ, it's going to pop from the end, but we just want to be popping from the front. Okay, and the RNC is going to be equal to, if we think of it in this case, at 0, 0. If we pop this and we were to print it, it would show 0, 0, right? So we want to get what's at the 0th index, the 0, 0 column, right, in this case. So yeah, we have that. Oops. And let me just make sure, sometimes my indentations are not right. Okay. We want to pop the left, and then we're going to say for current row, or we can say, yeah, let's say current row and current column, CC, in directions. So this is going to be an iterating now just over this, right? So CR is going to be the current row, which is going to be this. CC is going to be equal to this, the -1. We want to do row call is going to be equal to row plus CR. And then sorry, yeah, row plus CR and call plus CC, right? And that is going to be just saying we're going to have our new things. Our row is going to be equal to the row at the first thing that comes off the queue and the current row in directions, right? So it's going to be taking this 0 and we're going to be adding these things together. This will allow us to check in all the 4 directions. So we're essentially just adding these together so that we don't have to do this math inside this next check, right? So once we get out of that, we're going to say if the row is less than 0, right? We need to check. This is checking in bounds. So I'm going to make a note here. We're checking bounds and if equal to 1. Okay. So if a row is less than 0, right? We're out of bounds. We don't have that. Or a row is equal to the length of grid. So equal, if it's 0 index based, if our current rows are equal to the length of this, you could say greater than or equal to, but it's essentially the same thing in this case. Or call is less than 0. Oops. Or call is equal to the length at grid 0, right? Equal to the amount of columns. And let me do this. Or our grid row call. So this grid row call is going to be equal to what we're currently looking at, right? We're going to be checking all 4 directions. So if the current position that we're at is not equal to 1, then we're just going to continue, right? Else, we need to actually do something, right? So this is in the test case when we're actually equal to 1. When grid row call is equal to 1, right? Else, if that's the case, then we want to do grid row call, and we're going to set it to 2, means we're going to make it run, and then we're going to do q.append, and we're just going to pop in or push in, sorry, the current row and the current call, right? So that's going to be, we check the 4 directions. If one of them is 1, we're going to change it to run, and then we're going to push it onto the queue. And then we're just going to increase, or going to decrease fresh oranges, sorry. Minus equals 1. So this is going to decrease the amount of rotten oranges. Then when we come outside of this, yep, right here, time is going to be, after we break out of this for loop for all the things in there, right? Time is going to be plus equal to 1, which means 1 minute has elapsed. And then if we break out of the while loop, this is important. So now that we've done all of this, we have to make sure 2 things are case, right? We have to make sure that in this case, the queue is going to be empty. But if there's still fresh oranges, right, we just return -1. So we want to return time if fresh oranges equals 0. Right? Does that make sense? Because if in the test case we had right here, or at the very end we had that 1 at the what was it, the 2/0th index, and nothing was able to hit it, else we just return -1. So if there's no more fresh oranges, right, if fresh oranges is equal to 0, we return 0, else we're going to return -1. So let me get rid of all this, and let's run our code. I should have run it first. Line 15, let's see. Directions, oh, sorry, directions equals, I didn't set this equal to it. And I believe that should work. Yeah. So I just forgot to set directions equal to this. I just said directions that. So here we go. It's better than 65%. You can kind of run it a few times. Oops. You can kind of submit it a few times. Usually it just kind of goes whatever. But yeah, I really appreciate you guys watching. And I hope to see you guys in the next video. Thanks again.